This is the screencast for section 3.6, example 8. Okay, annuities are a different type of investment than we've been dealing with in the last several examples. The last several examples have been situations where you take a chunk of money, sit it in a bank, and let it stay there. And you don't do anything to it, you just let it collect interest. Annuities are different. You are paying payments monthly. So whether you are saving up for something and you're paying to an account monthly, or maybe you are paying back a loan monthly for a car or a mortgage or something, or school loans, or maybe you are saving up for school or saving up for retirement. Those are annuities. You're paying monthly. It's not like a bill, because a bill is not something that you owe a large sum and are paying it back. A bill is a monthly, here's what you owe for our services this month. It's not the same. This is an annuity where you are paying back something that somebody has lent you. Now, future value of an annuity are investments. So you save for the future. So I remember this future value equation. First of all, you don't have to memorize this, but when you save for the future, the exponent is positive. The present value that you'll be learning in the next example has a negative exponent, and that's a loan. So loans have a negative amount of money. This is a positive amount of money that you are saving. So that's this future value equation. The future value of an annuity consists of n equal periodic payments. So you might be paying monthly towards this savings account. You might be paying quarterly towards this savings account. You might be paying annually. I don't know. And then you are paying R dollars per month, and then an interest rate I per compounding period. So that's going to be your percent divided by your payment interval. So let's look at example 8. At the end of each quarter year, Emily makes $500 payment into the Lanigan Mutual Fund. If her investments earn 7.88% annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years? So this isn't like she's taking her $500 and setting it into an account and letting it sit there for 20 years. She's actually making $500 payments, which is quite a bit amount of money, every month into this savings account. So to set up her future value, we are trying to solve for her future value actually. We're finding out what she has saved in the future. Her monthly payments, her R value, are $500. In the numerator, I have 1 plus. Now I is her interest rate per compounding month. So that's 0.0788, 7.88% per. She's not paying monthly, she's paying quarterly, right? Yep, each quarter year. So that's going to be over 4. Now N is the total number of equal periodic payments. So she's making these payments quarterly for 20 years. So that's 4 times 20. So she's making 80 of these $500 payments. Now we need to divide this whole thing by the I value, that fraction, 0.0788 over 4, her percent divided by the number of payments she's making per year. Per compounding period. So now I'm going to simplify this, or figure out what that is in my calculator. Alright, so I also realized I forgot the -1 in the numerator. Maybe you already figured that out. But I put all this in my calculator, and I got that she's going to have earned $95,483.39. So $95,483.39 is how much she will have earned as a result of her 80 $500 payments. So looking at that, what is her 20 times, we said 80 times 500. She technically made a $40,000 investment. So for an investment of $40,000 total over a series of 20 years, she will come out with $95,483.39. Not bad. If you've got an extra $500 a month laying around, go for it. Invest in something like this. It sounds like a great deal. Now try problem number 13. Find the future value, FV, Accumulated in an annuity after investing periodic payments are for T years at an annual interest rate R with payments made and interest credited K times per year. So we've got all this information, kind of boring, no person's name or anything. Don't know what they're saving up for, but that's okay. So future value of this will equal, we've got $500 payments again, how exciting, and then 1 plus, let's see, a 7% interest rate compounded K times per year. So this one's also going to be quarterly. So that last one was 500. Yeah, we figured that out right. Okay, $500. I might have said monthly, but this was actually quarterly. So this one's quarterly, and she's, or he, or we don't even know who is doing this for 6 years. Minus 1 all over, and then we have our I value in the denominator again, so 0.07 over 4. And I'm going to put that in my calculator. So this person, after a series of 6 years, will have $14,755.51. Now they made $500 payments for 4 times a year for 6 years, so 24 total payments of $500. So they made $12,000. That's a $12,000 investment that resulted in that almost $15,000 over 6 years. So again, pretty good.